What's up, guys? Welcome back to the podcast. Today we've got a special guest. We got some of the crew from PSB Audio. Paul, Mr. Paul Barton.
Hi,
What's up,
everyone.
Paul? So, Paul, I've got some of the Alpha series in for review, and I've been checking it out for the past month and a half or so. And I believe you're going to give us a little history on the Alpha series and also a little history on PSB speakers.
Yeah, I'm going to start with a little PSB history for those of you who don't know the background to the company. So I'm going to talk a little bit about the history and then talk about the Alpha series, which Shane is reviewing right now. It all started, as you can see, at a very young age, where I studied violin from age 6 until I took lessons until age 19, and acquired a good taste for music at a very young age. So music is sort of the way my brain has been wired. And then when I was 11 years old, as I got older and larger, I needed from a half size to a 3/4 size to a full size violin. And my father at the time really didn't have a lot of money. He was a musician, a tenor, also played the cello, and decided that instead of buying a violin, which was pretty expensive, he decided to make me one. And this is actually a painting of a photograph that was taken in that day, and actually it was painted by my daughter. And you can see up in the, just beside me there, is the frame which the violin is built around. And after 2 years, a year making the tools for the violin and a year actually constructing the violin, it was completed when I was 11 years old. And I still have that violin. Don't play it as much as I did when I was younger, but I still do. Of course, the objectives for PSB was to, produce good loudspeakers. When I was in high school, I joined up with 2 high school buddies and myself. In the summer of 1972, we rented a place just north of the city I came from, little town called St. Jacobs, Ontario, Canada. And we, struggled for a few years trying to, establish a company. The September after the summer we started, which was the summer after I finished high school, I went back and went to the University of Waterloo engineering. At the same time, running the company. And I was on a program which they have, which is called a co-op program. You go to school for 4 months, and then you find some related business that you're interested in engineering to get some experience. So in my case, I employed myself, and on my work terms, I worked at PSB, and on my school terms, I went to school. Not to mention that I actually worked every day. It just didn't work during the day when I was doing my school terms. And then in 1974, I was introduced to Dr. Floyd Toole, who at the time worked as an acoustician engineer at the National Research Council, which is a government-funded institution facility, sort of a think tank in Canada. It's in the capital of Canada, Ottawa. And it had a specialized division in the physics department under acoustics, and Floyd worked in that group. And I was introduced to Floyd by a magazine editor in Canada at the time, who was using the NRC to actually, in the anechoic chamber you see here, making measurements to evaluate loudspeakers for the Canadian magazine. And at the same time, they were actually doing some preliminary, subjective evaluations after they did the measurements of the loudspeakers. And that sort of evolved. And by 1974, Floyd, when I met him, Floyd was already starting to do subjective versus objective measurements of loudspeakers, and that is measuring them in the anechoic chamber and then comparing the results of subjective evaluations with those measurements. And really, that's the foundation of what's happened in Canada. Here is an aerial view of the campus at the National Research Council. This river behind is the Ottawa River, near Ottawa. And all of these buildings, there's about 65 of them, are in all of the sciences, like aerospace, physics, building research, where they study buildings and how to build them efficiently. What other? There's also, well, just basic agriculture and medicine, all of these different sciences, all in one place at the National Research Council. And it employs about 1,000 PhDs in all of the sciences. And the facility that I use, I don't know if you can see my cursor, is just in this little area here. And it's a building called M37. Actually, the building on the right is the M50, which is the main building, administrative building at the National Research Council. So based on these listening evaluations, here listening is the final analysis of a speaker quality and is the basis for selecting speakers for domestic applications. How measurements relate to listening perceptions is always the question. And that was something we wanted to pursue. See, why did that speaker sound better to us than that one? And then compare what it's doing with people's subjective liking or disliking the way it sounds. So all of these parameters for doing listening evaluations were established at the National Research Council. Much of this work had been done around the world before, but I don't think as comprehensive an evaluation using competent measurements, good interpretations of the measurements, and comparing those with subjective people's, whether they like them or not. And really, here are the conclusions. Most of the people, most of the time, agree on the relative qualities of a group of loudspeakers. That means that there really is no personal taste. There really is no East Coast sound, West Coast sound. Musical taste and musical experience seem to be no prerequisites for being a good judge of sound quality. Meaning, just because you say you have a tin ear, if you've got normal hearing and you've lived in the world and listened to natural sounds, you are a good judge of sound. You can hear colorations. Sometimes it takes longer for people who aren't experienced, but when given the task to choose what they like, they seem to all gravitate towards good loudspeakers. There's no personal taste. And then finally, a properly interpreted set of objective measurements, measuring the loudspeakers, correlates directly with subjective evaluations, listening to the loudspeakers. And boy, is that ever a lot of good information when designing a loudspeaker. Is it tells me what those target things need to be, what the most important things in making a speaker produce sound at a good value, good price. So the history of the Alpha was really, it spans now 30 years, no, 29 years. Actually, I started designing it in 1991. And it really was released early 92. And so it's a 30-year-old project, starting with the very first Alpha, which was reviewed by John Atkinson in July of 1992. And, or actually, it wasn't John Atkinson, it was Jack English, a writer for the magazine at the time. And it got a lot of accolades and really launched our entry-level product into the world, all over the world. And it is a good success because it still continues to be a position in our product line with a similar philosophy on how it's built and what the priorities are in terms of making a good speaker for good value. And then another generation came along, Alpha Series, and here's an image of it at the time. Just some slight cosmetic changes. I upgraded the drivers in it. Went from a 1/2-inch polyamide flare dome to a 3/4-inch soft dome. And then this went to an aluminum dome with a polypropylene cone. This was the Alpha B1, and we built this one the longest period of time. And it also had a tower in the line along with it, and also a center channel. So the whole product category and what we're offering and the price points that we're offering has been a staple for PSB for 30 years. So this is the lineup that we're currently talking about here. The only one that's not in this review is the smaller bookshelf, which we call the P3, and it uses a 4.5-inch woofer instead of a 5.25. And it's available in 2 finishes, black, ash grain, and walnut grain. These are just some beauty pictures of it. So that's the P3, that's the smaller one. And I'll explain in a minute what the driver arrangements are. I know there were 2 things in your unboxing video that I looked at. One was the question about why the tweeter was below the woofer. Well, when it comes to, the fact that the tweeter is not in the same acoustic place as the woofer is, there is going to be a discrepancy in terms of the time it takes for the sound from the woofer and the time it takes from the sound of the tweeter to arrive at you. And that will be different depending on whether you're standing up or whether you're sitting down or whether you're on the floor. And because they're not in the same, they're not coincident. So, and it just so happens that you've got to crowd them as close together and cross the tweeter over as low as possible in order for the 2 to sum. But by putting the tweeter below the woofer and using what I can describe as a 4th order Linquist acoustic filter, meaning the combination of the passive filter components and the woofer's natural roll-off and the tweeter's crossover components, passive components, and its natural roll-off can be combined to create a 4th order Linquist shape. And what that does is the lobe tends to tilt in the direction of the woofer. So when you're listening to this speaker, when you're sitting down and then you stand up, it sounds very similar. And that's the reason why the tweeter is below. Now, if I put a step baffle in, I could put the tweeter above and play with that, but the design is meant to be very simple. When it comes to the tower, by the way, because of its configuration, well, here is just a closer picture. Before I go into that, I'll just mention one thing that you mentioned or had in your box opening was the grill seemed simple, which is what the intent was. And one thing you can take advantage of with a grill of this slimness and this thickness is if it's close enough to the tweeter, which is where it affects it the most, the tweeter doesn't even see it because it's less than a half a wavelength away from the source. So it doesn't reflect off the grill. And that way the grill virtually is transparent. The speaker sounds the same with the grill on or without the grill. It has no frame, which can sometimes interfere with the phenomena called diffraction and makes the response a little bit ragged. Without a grill, or sorry, without a frame, you eliminate any problematic things with regard to that. It is a fairly flimsy grill, and the reason for its thickness is because of this transparency that I'm looking for. If the grill gets any thicker, it starts to interfere with the tweeter's response. Another thing I'd like to mention about the tweeter is that it's an aluminum dome with ferrofluid, which was mentioned in the unboxing, but it's also in a waveguide. And one of the things you try and achieve with a loudspeaker that has more than one driver in it is the directivity, the dispersion of the woofer at its highest frequency, where it matches up with the tweeter. And because the woofer is large, as the frequency gets higher, it starts to interfere with itself, so it has less dispersion. And the objective here is to get the best dispersion you can out of the woofer, but at the same time match the dispersion at the crossover frequency of the tweeter, so that off axis they blend very well, and there's no kind of roll off of the woofer and then the tweeter coming on strong. Because when you think about it, in a room, the first acoustical sound comes directly from the loudspeaker. The next sounds you hear come off what we call the early reflections, the sidewalls, the ceiling, the floor. And sidewall reflections way off axis, typically in a normal stereo setup, could be anywhere from 60 to 75 degrees off axis. Believe it or not, is the second sound you hear in the room. So, and because it comes so quickly in time, your brain hears it as one acoustical event. And I'll give you an example of that phenomena that our brain does when you're in a room. Sometimes I'll ask people, when you're talking to someone on a speakerphone, do you know they're on a speakerphone? And most people say, yeah, I can tell they're on a speakerphone. And I say, well, how do you know they're on a, what is it about the sound that makes you know they're on a speakerphone? They say, well, and we talked about this a bit earlier, I hear an echo. And yeah, they say, yeah, I hear an echo. And I say to them, well, when you're in that room, do you hear that echo? And they think for a moment and they say, well, no. And I ask them, well, why do you think you don't hear the echo when you're in the room, but you hear it when you're on the speakerphone? And quite frankly, it's a psychoacoustic phenomena. Our brain has been programmed to integrate early reflections so that they don't cause a lot of confusion and allow us as mammals to survive, because we can, in a reverberant or reflective environment, we can target where the original sound comes from with great clarity. And so when you're listening to speakers in a room, what you hear off the sidewall combines with what you hear coming directly from the loudspeaker, because it arrives in such a short time that you integrate those signals, and the timbre of that combined sound is what you hear. So creating some controls over the directivity and the crossover point, as simple as it looks in this design, a lot of thought goes into that. So that's kind of the basis of the industrial design and the way it's been implemented. One other thing I'll mention is the cone has a texture on it. Well, that embossing on the cone actually kind of stiffens up the cone a little bit, which is a good thing. And there's other ways to stiffen cones. You can add mass and you can use exotic materials, but you can sort of play around and get something that's a little stiffer, even though the mass doesn't go up. And we don't want the mass to go up on a little speaker like this, because we want to get the most sensitivity out of it as possible. Another feature on the woofer you'll notice is the surround is not a half round. There's a little bit of a fillet in here. And if you did a cross section of this, you'd notice that it's thicker right at this, where it starts to swoop down. The other side is a sharp edge, whereas the top side isn't. So it adds a bit of mass all the way around the surround. And that, in balance with the mass of the cone and the stiffness of the material, helps to stop the reflection from the center off the edge and reflecting back, which we call, it's a phenomena with a driver as the frequency gets higher, where it starts to break up and cause reflections. We call this an edge hole. It's a reflection off the edge. So creating a shape that is conducive to adding a bit of mass around the outside, tunes this thing quite nicely and sort of balances the whole thing out. Another thing I do it's a little more expensive than the typical white fluff that you see inside inexpensive loudspeakers. This is a material which is really a felted material, better known by us as a bicomponent material. It's got different densities of material in it, and it's used a lot in the upholstery business because it's a fairly natural fiber. It's just natural fibers ground up and creating padding, but it works very well. Just to explain a little bit, that white fluff you often see in loudspeakers doesn't really do anything to damp the sound in an enclosure, because the mechanism that damps sound using damping material, whether it's inside a loudspeaker or inside the anechoic chamber, which also has damping material, in that case fiberglass, which is also a good damping material. Sometimes difficult to get people to handle fiberglass when manufacturing a speaker, and so this is a lot more user-friendly as well. And the mechanism that damping material does inside the loudspeaker is that all of these fibers are not attached to each other. They're compressed against each other, and when you put sound through them and the air molecules are moving, the fibers rub together and turn that energy into heat. That's the mechanism that takes place. That white material that you see in loudspeakers, all the fibers are bonded together. So if you try and tear it apart, you don't get fibers, you get all this mesh. Well, there's nothing to scrape together. It just doesn't scrape together. They're attached to each other. So there's less friction. And so it doesn't make for a very good material.
Makes for good pillows.
Say again?
Makes for good pillows.
Makes for good pillows. Yeah. Yeah, that's right. And it's hypoallergenic. So that's another benefit. And this is just a review that came out not too long ago, or not a review, it was a summary of the recommended components from Stereophile this past year. And the Alpha got the budget component of the year, and John Atkinson at the bottom, you'll notice, also picked it as his choice for the year. So it's getting some good recognition.
Mm-hmm.
The T20, which you're working on, is a very similar configuration, except that it's a dual woofer cabinet. It has plenty of bracing inside. There's a brace behind each woofer, and then there's a brace towards the bottom of the cabinet. Same idea here, good off-axis dispersion. This is a two-way, and I use instead of a 2.5-way, and the tweeter is above because I use a Butterworth acoustic filter, which the lobe tends to tilt in the other direction depending on the phase. And because it's a dual woofer system, the power handling is not as big an issue. And the center channel, which also is quite well braced internally. And of course, all three of these models use that damping material in the proper places. Oh, one thing I'll do is go back to a slide that I had before and just talk to you. You'll notice that the positioning of the damping material is such that I've put it so that some of it is in the center of the cabinet. So inside the cabinet, at some point, there's going to be a standing wave relative to that air column inside the cabinet. And when that standing wave occurs, there's a high velocity point in a closed tube that occurs at the center. So that's where the air is moving. And the best place to damp the air move, or to damp the standing wave, is to damp it in the position where the air is moving, not where on the wall, on the bottom and the top of the cabinet. the air isn't moving. It's a high pressure point. So it can't, the fibers won't rub together, but they will rub together in the center of the cabinet because the air is moving the most at the standing wave inside the cabinet.
Let's talk about the height of those T20s.
The height?
Correct. The kind of mini towers.
Yeah. They're sort of inobtrusive. I didn't see them in your setup. I guess that'll be shown when you do your review. Getting it too big, it becomes a cost proposition. The idea here is to try and optimize all of the parameters. And one thing I was shooting for here was in a small tower, trying to get some deep bass out of it.
Mm-hmm. Would you recommend tilting that upwards a little bit? The front of it, like give a little.
Well, it depends on where you are and where your ears are. The height of your ears in the room, the height of your chair. There might be some subtle improvements or change when you slant the speaker back, but that'll be something I would recommend you do just subjectively. I can't predict all of those parameters without knowing how high off the floor your ear is, and how tall your chair is and how tall you are and all of those things. So it's something I would maybe recommend experimenting with.
Oh yeah, definitely.
And then there's the subwoofer. And one thing I'll just mention about subs is, and I tried to keep a pretty clean look. By the way, the grills are made of steel, and the magnets that hold the grill on are actually embedded right in the baffle behind the finish. So, so that's why you don't see any magnets. The magnets are buried inside. They're pretty powerful neodymium magnets.
Yeah, they stick pretty good.
And what else was like? Oh, I just wanted to talk a little bit about subwoofer design. Nowadays, there's a lot of DSP amplified chips available, which we implement one of them in this design. And what it allows me to do is two major things. Number one is to really intelligently know the limits of what the subwoofer can put out, so that there's no risk of overdriving or making it go crazy, because it can sort of know where its limits are and control it quite well. And, lots of subwoofers have limiters, but this one is something that's more related to something can be described as dynamic EQ, so that it knows where its limits are and maintains the best EQ it can at the highest possible level, but keeps monitoring that based on the setup. The other thing, a typical bass reflex loudspeaker, which is what this is, you want to tune it so that it's a good balance between sensitivity and the 3 dB point down or the 10 dB point down. Well, when it's a powered sub, and of course, a bass reflex loudspeaker, how it behaves is that at the tuning frequency, the lowest frequency of the system before it starts to roll off, and that's where the port is doing the most work, at that frequency, the woofer hardly has to move at all. So with that in mind, I can apply, or I can tune the box down lower than I normally would tune it if it was a passive loudspeaker. And then I can EQ it to boost at the lowest frequency, which I've now tuned lower, knowing that the woofer will hardly have to work at all at those frequencies. And that's the beauty of designing a bass reflex system in a subwoofer, to get the best bang for the buck and the bandwidth and the lowest distortion, because you're able to make most of the work that the woofer would have to do, say if it were a sealed box, at the frequency where the woofer is hardly moving at all and the port is doing all the work. And that results in quite a bit lower distortion, down to the tuning frequency of the loudspeaker. The undertuned or overdamped of the tuning, and then making up for that overdamped response with EQ at the port tuning frequency. And here's just another view of the campus, and I just wanted to talk a little bit about an experiment that I did a couple of years ago with a press junket that we brought up to the National Research Council. And the objective was to try and determine what target curve a headphone had to be. And because when you listen to music in a room on speakers, the room is part of the filter you hear, not only in your home, but also when the musicians and the engineers and the producers were auditioning it in their rooms, or the mastering was being done in a room, so that the room's effect and what the person heard would be part of the equation. So when you measure a speaker in the anechoic chamber, or if you listen to a speaker in the anechoic chamber, because there's no standing waves and because there's no reflections, most people would say has no bass. Because when you put that same speaker, which has a flat response, in a room, a direct radiating loudspeaker, which is basically what we're talking about here, has wide dispersion or omnidirectional output at low frequencies. But as the frequencies get higher, the dispersion narrows, gets more narrow. So that if you look at all the energy the speaker is putting out, it's not flat, if it's a flat speaker in the anechoic chamber. So having, with that knowledge, then when you put a speaker in a room, the room is going to reinforce more low frequency because it's now reflecting off the walls because the energy is omnidirectional. So we did a lot of experiments with saying, well, okay, if we want to take a pair of headphones or even EQ a loudspeaker in a room, what should we set the target curve for? And I can tell you right now, if you set a room to be flat, most people would say it has no bass. And it's because the recordings that we listen to were recorded to be played back on speakers in a room. So if you don't create or recreate that premise, then it isn't going to sound the way it was intended. And if you apply those curves to a headphone as well, we call this room feel, you can see it in the top of the slide there, that's sort of implying that we've taken into account the effects when you listen to music on a headphone that was recorded to be played back on speakers in a room. This should correct for that. And we did an experiment. Here's a pair of our T3s, the Imagine T3s. There's also a speaker in the center, which this photograph, I was just using that speaker to do calibration in the chamber. It later got removed when we did the listening tests, and you'll notice there are two seats, one ahead of the other. So when someone is listening, two people could listen at a time, could both hear the system in stereo. They wouldn't be sitting side by side. You'll see on the floor there is a PC monitor, and the user had a mouse. Each user had a mouse, and they could select from different target curves and then use score sheets to make comments about the differences they were hearing and what their preferences were. And here I am just talking to a few of them as we were setting up the experiment. Right behind me is the door that opens to the outside world. And that grate we're all standing on, and actually the one that I show here, this grate isn't normally in there. It was just put in there for this experiment. We don't normally like to have the grate because it has some reflections if we're doing proper anechoic measurements. And then we also had a subwoofer in the system, and the system was calibrated, and we let the listeners judge it. So that's all I really had put together for you guys. I guess I can stop sharing my screen.
So when you are taking measurements, or when you're doing like sound tests with other folks, are you doing it in an anechoic chamber or an actual room?
Oh, no, no, no. Something that I didn't show, I could have maybe pulled up some slides, was what they call this room that we did or Floyd Toole actually did the blind screen did the blind screen listening tests. Basically, a room sort of evolved over time. And they did some early tests with the Canadian Broadcasting Corporation here in Canada when they were trying to select a monitor for all of their studios. Basically created a listening room that was later deemed as the IEC standard for listening room. That's a European standard for doing listening evaluations of loudspeakers. And they adopted that standard for the IEC listening room. So I have one at PSB, and a lot of the manufacturers that participated in the NRC work and developed products in conjunction. I mean, I went to NRC in '74, and then no one came to NRC in terms of product development, although Floyd was doing all of his research until 1982. So I was going up there for 8 years developing loudspeakers and trying to learn all about double blind screen testing. And over that period of time, the room evolved and eventually became the IEC standard for doing subjective evaluations. And the key to that room was it was very good dimensions where the standing wave problems were somewhat minimized. It was the proportions, it was what they call the golden proportion, 1 to 1.7 to 1.9, I think. And it also had some, which isn't very common, but had some treatments on the wall, some absorbers, and they were actually membrane absorbers. That was there for two reasons. One is at the NRC, all of the rooms were made of concrete. And so in order to simulate a more similar structure, and also another problem with listening to speakers, one person at a time is not a very efficient way to evaluate loudspeakers. So the room was configured in such a way in terms of absorbers and treatment to make it more similar reverberant time-wise than a normal room, which was about under 1/3 of a second in the mid-band reverb time. That's a RT60. And when we were doing, or when Floyd set up all of these experiments, one of the things that was a challenge was, well, how do we get a lot of data in the shortest amount of time? And the only way to do that is to be able to have more than one listener at a time. Well, of course, more than one listener means there's got to be four. If there were 4 listeners, there would have to be 4 places for listeners to sit in the room. Well, we got to make sure that each seat kind of sounds the same as all the other seats. And so some work was done in the room to try and normalize the distribution of standing waves into an area where all 4 seats were virtually the same. Now, in the listening tests, we also invited listeners to move into other locations so that if there was bias based on the speaker location and the listener location, they could mitigate that by moving around in the room a little bit. One thing I will also mention is, and this has something to do with what I was saying earlier about early reflections in rooms and how our brain processes things. We also learned in the course of these tests, or at least Floyd discovered, and I learned from that the first, if we had a group of people and you were setting up a session, you do maybe 2 sessions in the morning, 20 minutes each with 20-minute breaks, and then 2 sessions in the afternoon with 20-minute rounds with 20-minute breaks. And so you'd start in the morning with round 1 for 20 minutes. And if you put in 4 fairly good loudspeakers and let the listeners come in, and all of this is double blind, they don't know what's behind the screen, and neither does the operator. Only a third person knows what's behind the screen. So there's no bias inside the room. And listeners, well, I lost my train of thought. Oh, I
Removing
know
bias
what it
from
is.
the room. Okay.
What's that?
I was saying you're saying removing bias from the room.
Yeah, to remove bias from the room by moving around. And I know what it was. The first round of people we found consistently had scores that were unreliable, unpredictable. I often would see people come out of the listening test of the first round with, 4 decent loudspeakers, and they would say, they all sound the same. And part of it because the room initially will dominate what you hear. And it takes time for your ears to adjust. Some people call it speaker break-in. Well, I call it brain break-in, because it takes time for you to sort out the reflections, figure out what the room's doing, and figure out the differences between the loudspeakers. So we put people in the room for the second round before lunch, maybe juggle the speakers around a little bit and change the numbers that they were pressing. They would come out of the room with the same group of loudspeakers and say, what did you do? They're all different. They all sound hugely different. So we learned over time that there is some period of time, and it takes about 20 minutes for a person to sort of sort out the room and get a sense of the environment.
And then when you're taking these measurements in a chamber, and then let's say a customer somebody buys a speaker, puts it in their house.
Yeah.
Obviously, it's going to sound radically different than what you're getting in a chamber. So when you say these measurements correlate with what people are hearing, I mean, how much of an effect does that room have to play in the original measurements?
Well, what we do is we listen to the speakers in the room, and we have varieties of rooms, but the one that was in doing all of this research, the one that was used is the IEC room that I mentioned. And what we do is we put the speaker without knowing what the measurements are, and we put a group of them in there, and we listen to them. And we say, I like that one, I don't like that one, I like that one, I like that one more. And then we go and put that speaker in the anechoic chamber so that it's a controlled environment. And I can measure only what the speaker is doing, because that's the source of the sound in the room. I want to know what that speaker that was in the room measures like, so that if I want to make another one like it, I can do that, because I know how it measures in the anechoic chamber. And then when it measures like that in the anechoic chamber, when you put it in the room, that's the one you like. Does that make sense?
Yeah.
I hope that answered your question.
So if you're buying a speaker, like without even hearing it first, just browsing online, you're just looking at the measurements. Let's say 2 different speakers have the same, response curve. Should they sound the same?
No, because the measurements that you see that other people publish are very limited. Remember I said 60 degrees off axis is the second sound you hear? Not very many people measure and publish their measurements 60 degrees off axis. So you can have a speaker that's identical in frequency response off axis, but the sound power, the total energy it puts out all over the place, which eventually bounces around the room, and some of it gets to you. Not all of it, because some of it actually turns into heat. But a lot of it, depending on how reflective the room is, eventually chatters around the room and gets to you. And that we call reverb. So there's 3 sounds you hear in a room. One is the first arrival, the sound directly from the loudspeaker. The second sound you hear are early reflections, as I mentioned, off the ceiling, the sidewall, the floor. And the third sounds you hear are the tangential reflections that eventually rattle around the room, and we call that reverb.
Okay. Is there a specific curve that you guys aim for? Do you find people like a flat curve more, or maybe like a V curve more, smile curve, or bumped up one way or another?
I guess there is some level of personal taste in a loudspeaker, but I think the best way I can describe it is a speaker, really, the analogy with light is that it is transparent. It's like a window through which you see the original acoustical event. Now, if that screen has a smiley face, that might be like saying it has a blue tint to it. Well, sometimes, you put on sunglasses and things sound much more spectacular than they really are. They look more spectacular. And some people might like that. Some people might like, wow, that's bright, that's spectacular, but it's not natural. Mm-hmm. And when you buy a PSB, you can put on sunglasses if you want. But if you buy other brands, sometimes you can't take off the sunglasses and it all sounds like tinted blue. So I'd like to think that the frequency response should be, and the sound power, the combination of the two, looking at the directivity of the loudspeaker, should be balanced, flat, and equal energy all around this, or not all around the speaker, but a balanced energy no matter what axis you're on. Doesn't mean it's totally flat, like 60 degrees off axis. It starts to slope like at 500, 800 hertz and starts to roll off. But you don't want the woofer at the crossover point to be giving up before the tweeter comes back on, because that second reflection, you'll hear this harsh sound coming off the sidewall, and that translates into, even though it's on axis flat, it sounds a little bit harsh because combined with the reflection off axis, where the tweeter's got too much energy and the woofer's rolled off, you hear that timbre that's created by the combination of the direct sound and the reflected sound. Even though it looks like a simple speaker, there's a lot going on when you put a speaker in a room. And your question was centered around, well, if you measure a speaker in an anechoic chamber, how can you tell how it's going to sound? Well, all it's doing is telling me exactly, without any other influence, of what the speaker itself is doing. And if I know what a speaker that sounds good in a room looks like in the anechoic chamber, then I can design speakers that sound the same or better, maybe.
Mm-hmm. Question for you, Paul, since you were talking about crossovers. In a floor standing speaker with dual woofers, are they connected to the crossover in series or in parallel?
In this case, they're in parallel. And on some of my designs in the past and currently, the way it's configured, some of them we call 2.5 ways, which means both woofers don't cover the same frequency range. In this case, with the Alpha, both woofers are 8-ohm woofers that are in parallel with one filter feeding both woofers, so that both woofers cover the same frequency range in the case of the Alpha. Into more expensive models, we get a little more sophisticated in the crossover design to try and, raise the bar a little bit on its coherence, so to speak. Not to say that what balanced, I've used the right kind of filter when you use two woofers together. It's complicated because there's all kinds of things related to phase, distance the woofers are apart relative to where the tweeter is. All of these things get taken into account. And I'm not satisfied with a crossover for a design like that unless it fits the criteria that I outlined when I do the sitting down to standing up, making sure that at the crossover point, there is no suck out because of the change in distance you created by moving your head from the seated position to the standing position. I'd rather have the in-phase lobe, is what we call it, where the ears reside in a room and not where they don't reside. I'm sure you've read reviews. John Atkinson sometimes will talk about the listening axis and where the best axis is, and sometimes he'll even state that the axis is best below the listening position, which to me doesn't make much sense, because unless you're lying on the floor, it's not going to sound as good as it should.
Thanks for the question, Deepak. Another question for you, Paul.
Yeah.
Will you be making a version of the PWM3 as an in-wall instead of an on-wall?
I really don't want to talk too much about it. I mean, letting the cat out of the bag, but yeah, it's a product category that is in process right now. Thanks for the question. It just gives me some confidence that we're doing. Our roadmap is intact.
Can you talk about the WLCR and the WLCR2 in-wall speakers, what they have to compete with other brands?
Well, it was based. It's currently based on our Imagine series, which is our current flagship, and using a lot of the components that were used in it. And one thing I did with that design is I making it a flush in wall on the side walls, and then the LCR. And one of the challenges was to try and get the performance. We had to design special magnets and to keep the depth of the cabinet shallow enough and still have enough excursion and power handling capacity for a high-end offering. How they compete with other brands, I don't know what else to say except I think they sound better. I've used the same criteria, although designing a speaker that goes in the wall presents some other challenges: mechanical vibrations, isolation, cabinet structure, and the fact that it's, when a speaker is freestanding, it's in what we call a 4-pi mode. It's sending sound at low frequencies all around it, whereas when it's in a wall, we call it a 2-pi, half a sphere. And so when I'm designing a 2-pi loudspeaker, I actually put a wall in the anechoic chamber to simulate the boundary that it's going to be on, so that I can better match and predict what the bass balance will be when it's on the wall. And any parameter, like when I'm designing a normal loudspeaker, I really don't have much to say about where it's going to be in the room, where you're going to be in the room, and what the room is like, or where you are relative to the walls in the room. I have no idea what that's going to be. At least with an in-wall like that, I know at least one parameter, and that is it's going to be in the wall. So it makes it a little bit more predictable, I guess.
How different of a sound is an in-wall speaker to its
counterpart?
Yeah.
I would say very close. You could almost put one side by side in a room, have one in the wall and one sitting on the floor, and you could switch between them, and you could even measure them in the room, and they would be very similar. Mm-hmm. And that's all to do with just knowing where it's going to end up and what environment or what the room contributes when it's freestanding. And of course, that will depend somewhat on the position of the loudspeaker and the position that you are in the room. These are all things that you can adjust to make things work better in a room. And of course, you use 2 subwoofers, and I think you told me, or you said in the thing, you were going to use one in the front and one in the back.
Yeah.
Is that what you ended up doing?
I mess around with it. I think the best for my room was in that situation. Yeah.
Okay.
Like opposite quarters.
Were you closer to one sub than the other?
No, I'm like dead smack in the middle. They're like.
Say again?
I'm right in the middle between them. Well, between them both. One's like in the front left. One's in the back right.
Okay.
Yeah.
So in the corner.
In the corner, yeah.
Yeah. Okay.
Yeah.
All right.
Yeah. I mean, I can get it to sound pretty close if I put them in the both front corners, but I think for those 2 particular ones, it sounded better in the opposite corner.
Okay. And did you experiment a little bit with the level of each relative to each other and the main system? And did you play around with phase a little bit?
Oh yeah. I took some measurements on it. I'm gonna post a little quick measurement on the video, on the review as well. Pretty good, really good for 210s. Gotta say.
What did you use to do the measurement?
I have a mini DSP and the Room EQ.
Oh, okay.
REW. Yeah. No, not near field or anything. I take it from. I like to take it from my main listening spot, so you guys know what I'm actually hearing instead of
Yeah. Do you
from the sub itself.
Do you do a multitude of averaging around where your head is?
I could do that. I have a.
It makes it makes the messiness go away, and you can see the energy better.
Yeah. I mean, I don't know how many measurements I took. I took a lot though. I took a bunch because I'm always a mess. Because I don't know. I have like 12 subwoofers here now, so I spend so much time taking multiple measurements everywhere, just try to get it right with phase and distance and everything.
Yeah.
But it takes a while, but it's impressive for those subwoofers. Yeah.
Has anyone else asked you to turn all 12 on at the same time?
No, I could, but no, I'm not going to do that though. I'd blow my windows up.
Yeah, what that reminds me of stuff that you go to consumer shows in my past, and you have a whole bank of loudspeakers at the trade shows, and they're all sitting there in their glory, and some idiot would come in and go, "Hey, can I hear them with them all on at the same time?"
I did pair them with my two front left and rights, just so I can kind of cross them over so they almost sound like a full range. And then I have a couple of big 18s that I use just for LFE, and it works. It worked really well for that too.
Oh, good.
Yeah. I also took one as a center channel subwoofer, which also worked awesome as well because they're not big and hulking. They actually pretty punchy and tight just for the center.
Yeah.
But let's end this on a positive note here. I own 13 pairs of PSB speakers, T65s, T45s, C60, 3 pairs of B25s, and S50s. We got a PSB fan in here in the chat.
Wow. Well, what can I say except thank you for your support. And based on that, I'm sure you tell all your friends as well. So thank you. And, lots more coming down the pipe. I'm not finished yet, if you know what I mean. I've been doing this actually. Next year will be my 50th year. I registered the company in Kitchener-Waterloo in June of 1972.
Yeah,
that was the summer I finished high school.
Huh.
And I registered the company and never looked back.
A little bit older than me.
Yeah, it's been and is a fun career.
Yeah, definitely, right? Just playing with speakers, listening to music.
It's hard to do something for 50 years and not get something out of it.
Yeah. Well, all right. Well, thanks, Paul. Thanks, David. Can I just say I'm looking at David's face for the past hour. I'm like, this dude looks like Johnny Depp.
That's very nice of you to say.
What did you say?
I said David's just sitting there quietly. I'm like, he looks like Johnny Depp.
Oh. I've never gotten that before. No. No. But thank you. I'm flattered.
But all right, guys, thanks for being here on the chat. Thanks for checking out the podcast. I'm going to post this up on iTunes and Spotify and like Google Podcasts. If you guys want to listen to the audio portion of that, you'll be able to find links down below in the video's description. So check that out. Visit psbspeakers.com. Be on the lookout for my review of the Alpha Series speakers. I got all 7 in here, 2 subwoofers, pretty awesome speakers, especially for the price. Thanks again, guys. We'll see you in the next one.
Nice to see you. Bye-bye.
Yeah, bye.